Hi, everyone. Thank you for joining us and welcome to the online causal inference seminar. So today we are very pleased to announce a talk by Sander Beckers from University of Tübingen. He will be giving a talk on causal sufficiency and actual causation. And after that, we will have a discussion by Thomas Icard from Stanford University. So we look forward to hearing these talks and discussing. The seminar is being recorded, so just keep that in mind if you are raising your hands or asking questions, and I will take it over to Dominic, who is handling questions for today.
Thanks, Emma. So as usual, we're gonna please submit your questions via Q&A. We don't have a collaborator in chat today, so during the breaks, I will bring the questions forward to Sanders, or I will unmute you and you can ask the question live. So if you are selected, please keep in mind that the talk will be reported and might be posted online. Without further ado, let's get going. And Sanders, the stage is yours.
All right. Am I sharing my screen?
Yep.
Yes.
Okay, thanks a lot. And that's indeed what I should start with, thanking Ying for organizing and getting me here, and also thank Hito for, in fact, inviting me and giving me the opportunity to talk to you, because I'll have to do some stage setting, I think, before I can dive into the topic, because I don't really fit within normal contents of the seminar I would expect, meaning that I don't work on causal inference as such. My background is in philosophy and in artificial intelligence. And within artificial intelligence, my focus is on the theoretical side of causal models and the more conceptual questions. So then you might ask yourself, well, what is this guy doing here then, if this is a causal inference seminar? And that's indeed the first question that I'll be addressing. Why am I here? Why? Because it's a nice introduction into the topic, but also because it illustrates the topic itself, namely the question, why am I here? That's a question which is asking for a cause, a cause of a particular event, namely the event of me speaking to you. And we're wondering what is a cause of that event. Now, there are several causes I could give. The most salient one I'd say is that a few months ago, as I'm assuming most of you know, Guido Imbens, together with others, won the Nobel Prize in Economics. And that's how I found out about his work. And I was so surprised that the Nobel Prize was awarded for research on causation. I started looking into his work and I found this text he wrote about reverse causation. And essentially, simplifying a lot, he said, reverse causation is when you're considering, concerned with looking for the causes of particular effects, rather than the other way around, where we're trying to predict the causes, trying to predict the effects from particular causes. And he said, this problem is really important, but it hasn't received a lot of attention yet in the literature. And I was surprised by this statement because I've been working on actual causation, which is quite similar to reverse causation. And I think there's a huge amount of attention being paid to it. Of course, that's because I'm working within the field, but I'm not the only one. There's lots of people and there's lots of papers on this topic. So I emailed him saying, hey, wait a minute, what about actual causation? And so then he replied saying, well, you have a chance to present your views and explain a bit about explaining your work on actual causation. So that's how this came about. And so maybe that's a good way to distinguish or to conceptualize the overlap with causal inference and what the relation is between my topic and the topic of the seminar, is that reverse causation, actual causation, they're both concerned with looking at, from an effect, what are the causes, but there's a difference in emphasis. Now, the way I understand reverse causation is that it asks, if we have a particular causal model, might it not be the case that we're missing out on certain variables? So your model, assume that it simply consists of two variables, x and y, and you have a causal arrow from x to y. And it might be that you're asking yourself, could there not be a third variable, z, which our model currently does not contain? So the problem here is finding variables which we might have missed out on. Actual causation, on the other hand, starts with the situation in which we already know what the model is. At least the conceptual question of what it means to ask what actually caused what that conceptual question starts from the assumption that we already know what the model is. So even if you know what the model is, assume that we know it consists of X, Y, and Z, and assume also that we have a particular observation for these variables, then we might still ask the further question, okay, Y has gotten a particular value. Which of these other variables and their values were the cause for Y getting that value? Because it's not because certain variables are causally connected that they are the cause for each particular instance. So give a very simple example. Smoking causes cancer. That's a type causal relation. It says something about the types, about the variables, smoking and cancer. But there are many people who smoke and who have cancer, and yet it is not the case that it was the smoking for this particular person that caused the cancer. So there's a distinction to be made between type and token, right? So there's a distinction between relation between the variables and the relation between particular effects, so particular events, so particular values that variables can take. So that's a focus on, and that's one way to separate actual causation from reverse causation. And the other is, like I said, I'm assuming perfect knowledge of the causal model. So it's not an empirical question as such, it's a conceptual question. Okay, that's roughly a way of separating the two questions, but also showing how they still overlap. And in particular, they're motivated by the same interest, namely an interest in explanations. So we're not only interested in predicting when will a particular event happen, but also why did it happen? And there's of course, a long history in philosophy to discussing why we should care about explanations at all and what the relation is between explanations and predictions. And to a certain extent, you could say that we want explanations because they help us for in gathering future predictions. So there's an instrumental reason for our interest in explanations. But that's certainly not the only, or at least I would argue that's certainly not the only interest we have in explanations. I'd say they also have intrinsic value. And one area where this comes out is in responsibility judgments. If we want to hold someone responsible for a particular outcome, a crucial component of that is to figure out whether that person acted such that they caused the outcome. And we care about responsibility judgments even independently of any predictions that we might make in the future. But as I said, there is also a strong, you can say, instrumental reason for looking at explanations, in that getting explanations of effects helps you in finding out more about the causal model and about how to make predictions. And I've just recently actually written a paper which tries to analyze actual causation precisely using this notion of helping us find predictions regarding certain actions that we could take. So that's papers cited here. But other than that, I'll not be focusing on explanations. I'll be talking about actual causation itself and try to convince you that my approach is an improvement over existing work. Now, you might wonder, why is this even a hard problem? What's going on here? What are we trying to solve? And you might even wonder, is there such a thing as a concept of actual causation? Is it not merely something psychological? And this is a tricky discussion, but at least we can observe that in an overwhelming amount of cases and situations, there's universal consensus regarding what causes what. So that seems to hint that there's an objective notion at work here, because we agree on what's happening. But there's also cases in which there's very little consensus and it seems to be subjective. Now, let me give you just a trivial example. If I flip the light switch and the light goes on, then we all agree that me flipping the switch was a cause for the light being on. Sure. And the analysis we would give in this case is, if I had not flipped on the light, flipped the switch, then the light would not have been on. So that analysis invokes counterfactual dependence. So that's the idea that if a certain event had not happened, then another event would not have happened as well. And if that relation holds, that seems to be a very strong proxy for causation. And so that's the simple case, you could say. Now imagine that we're in a room with two light switches, each of which being flipped on is sufficient for the light to be on. Then, and imagine that both of them are indeed switched on. Then presumably you want to say of each of those light switches being flipped on that it is a cause of the light being on. Yet we can no longer analyze this in terms of counterfactual dependence. Because even if one of those switches had not been switched on, the light would still have been on because of the other switch. Now, you might even think of a slightly more complicated scenario, such that first one light switch is flipped. Okay, the light is on, that's a cause, that's fine. Then a little bit afterwards, someone else flips on the second light switch, but the light is already on. Still, we might wonder, is the second light switch being flipped on now also a cause of light being on? And intuitions can differ here, because on one hand, you could say, well, the light was already on, so what did it contribute? There's nothing more to be done. On the other hand, by the second light switch, by turning it on, you have secured the light being on to a higher degree, because now you need to switch off 2 switches before the light turns off. So it did change the situation. In any case, that's just a very simple example. There's many examples in the literature, many of them involving just a few variables. And it turns out that it can give you a lot of headaches trying to figure out how to come up with one analysis that deals with all of them. Then there's a third problem, namely, even if we agree on a definition of causation, that's one threshold to pass. But then there's a further threshold, which causes are actually interesting causes. That's a problem of causal selection. Trivial example again, if I light a match, then a fire starts. And so we can ask ourselves, what were the causes of there being a fire? Well, surely me striking a match is one of the causes. But you can also think, sure, striking a match, but there's also oxygen. If there's no oxygen, there's no fire. Therefore, the presence of oxygen is also a cause of the fire. Now, normally you wouldn't consider that to be an interesting cause. Why not? What explains that? So that's a problem of causal selection. All right. Now I'm going to get to the actual content of what I'll be discussing. I'll try to do so at a pretty high level because it's a technical paper and I surely won't be able to get into the details. I'll first say something about what work is out there regarding actual causation. And then I'll spell this out in a bit more detail using causal models and a family of definitions of actual causation called the HP definitions. And those are, let's say, the most famous definitions, but therefore they're also a good adversary to, or a good point of reference to which I will compare my own definition and try to improve upon those definitions. And I'll do so by using the notion of causal sufficiency, which will have a particular meaning in this context, as we'll see shortly. So once we spell out the notion of causal sufficiency, or at least spell out a family of versions, different versions of causal sufficiency, that allows us to define actual causation. And I'll discuss a bit how I did so and why I made the choices I did. In particular, in the last part, I'll show that we start out with 15 candidate definitions of causation, and I argue that only one of them should be accepted, namely that there's one which is superior to all the other definitions. I also see that there's something in the chat, but I'm not sure if that's important. I can't see what it says.
No, it's not a question. Yeah, so you can continue.
Okay, because yeah, regarding questions, I will stop at some point to see if everything so far has made sense, but more conceptual or philosophical questions, I propose we keep those until the end. So here's a very brief history of the recent work on actual causation. David Lewis is the one who introduced it in the 20th century. He invoked this idea of counterfactual dependence. That was an important starting point, but that's only one tradition, you can say. There's another tradition which is which was picked up in the 20th century by people like John Mackey and Richard Wright. And both of those traditions, Lewis's and Mackey and Wright's, they both have their origins in the work of David Hume. Now, this was done in a rather informal context, or at least when it was formalized, it was still wasn't very well known. And this all changed when Pearl, as you all know, came out with his groundbreaking book on causal models in 2000, due to presenting such a language, such a framework, work on actual causation could now be made much more precise, could be made much more formal than it had been before. And indeed, Pearl himself starts this work, starts this trend, because one chapter in his book is devoted to the question of actual causation. And much work that exists now has built on his initial attempt at defining it. Now, how does he go about defining actual causation? That's a crucial starting point for my work, because it consists of two separate strategies, and he very quickly moves on to only using one of those strategies. So he sets out saying, there's an intuition which is widely shared among scientists and people more generally, that causation is simply to be a necessary element of a sufficient set. That's what it means to be a cause. And that notion of causation, the acronym NES is used, was developed by Wright, but it's very similar to the analysis of Mackey. And so he says, that's a good fundamental conceptual starting point. Let's try to formalize that. That's one strategy. The second strategy is to just look at a whole bunch of examples and see what intuitions they evoke, and try to make a definition such that it gives the right answers for all of those examples. Now, those are two very different ways of going about it. And Pearl very quickly drops the first strategy and goes for the second strategy. And afterwards, in subsequent work with Halpern, they adjust their definitions in order to address concerns regarding prior definitions. And this is mostly based on counterexamples. So they present the definition, for example, in 2001. Other people write papers saying, here's some examples in which your definition gives counterintuitive examples. So they make technical adjustments to their definition to make sure that those examples are not handled. But there's no conceptual motivation for those changes. In particular, there's no definition of causal sufficiency. There's also no explicit definition of necessity. So although Pearl initially motivated the idea of causation using NES, necessary element of a causal set, of a sufficient set, he doesn't continue down that road because it doesn't define the key notions that are involved in that concept. So what I do is I go back to the beginning and I propose 6 definitions of causal sufficiency, and actually give a recipe for even more definitions, but those are the 6 ones which I'd say are most natural. I give 2 very straightforward definitions of necessity and use those 2 notions to offer 12 definitions of actual causation. And then I'll select from those 12 together with the 3 HP definitions. So HP stands for Halpern and Pearl, and I hope you've deduced from now. And there's 3 versions of those. So there's going to be 12 definitions I propose. There's 3 of the Halpern and Pearl definitions. So there's 15 in total. I'm going to argue that one of them is better than the others by using examples, but also by using principles and theorems and demand for consistency. All right, I'm going to go. This is going to be the fastest introduction to structural equations modeling. Partly because it would take too much time to go into detail, partly because I'm assuming most of you already are quite familiar with them. So this is just an example of what a causal model looks like in this context. It's a set of equations, structural equations, and the right-hand side is the cause of the left-hand side. So these equations are asymmetric, and they represent the causal relations between variables of interest. In particular, what we're interested in are the variables on the left side. Those are endogenous. So those are the ones that we care about, whereas variables which don't have an equation themselves, such as ux and uy, those are exogenous variables. So those are simply determined. We take them as given. And we're assuming that the models are acyclic, so that there's no, so that once we have the values of the exogenous variables, then all the other variables get their values through the equations. We can just fill them in and get applied through the model. So for example, we can then express statements regarding a particular causal model and a particular context. So the notation there, the M refers to the set of equations, and the couple 1, 1 in the first statement refers to a particular context in which ux has gotten value 1 and uy has also gotten value 1. So statements of causation, as they are about particular events, are statements which are always relative to a model and a context. So where a context is particular values for the exogenous variables. And in this case, we could have a formula stating that all of the endogenous variables take on value 1. Now, the use of causal models is, of course, to speak about interventions and counterfactuals. So we can ask ourselves, what would have been the case if x had been set to 0? And in this situation, if x had been set to 0, then z would have been 0 as well. And we can express that using the formula on the bottom. Now, we have hopefully enough tools to at least give the general format of the definition of actual causation that I'm presenting. And it consists of 3 conditions. The first one simply states that the things we're talking about, namely the potential cause and the effect, they actually happened, right? They actually occurred. That's the trivial condition. The third condition is also not that important. It just is a minimality requirement so that we don't add redundant parts to the cause. The hard work is in the second condition, AC2, which is, as I've suggested, what should be spelled out as the Ness intuition, so that X is a necessary element of a sufficient set. I'm using here vector notation just to denote sets, so that we're not focusing merely on singleton causes. The cause can be a conjunction of different variables taking on values, whereas the effect, I am assuming that that's a singleton, it's just one variable for simplicity. So the goal is to make the second condition, make that more formal. I use some notation, namely if I want to refer to the actual values of a variable, I use star. If I want to refer to counterfactual values, I use a prime notation. And so we want to have 2 conditions, sufficiency condition and necessity condition. Those are the 2 concepts that have to be defined. Well, maybe this is a good place to ask if there's already anything confusing that I've said or something which at least needs clarification before I can move on.
Thanks. So far it's clear, I think. At least I don't see questions in Q&A.
Okay, then I'm going to continue because there's still a lot more ground to cover. So what you see here is a very, very high-level representation of the Halpern and Pearl definitions. Namely that all 3 of them fit the general definition, so that there's 3 conditions, and they differ regarding the second condition, so AC2, which itself consists of 2 parts. Namely, for the original definition, the first part is a necessity condition. We can very straightforwardly interpret that condition as a necessity condition, so that fulfills the requirement that we're formalizing the Ness idea, necessary element of sufficient set. But for the entire definition to fulfill that format, we would expect the second condition, condition B, to be a sufficiency condition. Yet that's not what we find. All I'm going to say here is that it's a pretty complicated condition that they give. And in fact, when they changed their definition to the updated version, it became even more complicated. So there's no way of trying to conceptually understand that condition, or at least no way. There's no obvious way, no straightforward way, and they also don't give us a way in their papers to interpret that condition as a sufficiency condition. Lastly, then there's a modified definition, which is due to Halpern by himself, which only contains a necessity condition. Now, there's an important point I should make here, namely a first result that my paper shows that actually the modified definition does succeed in formalizing the Ness idea. And why is that? Because even though there's no explicit sufficiency condition, there is an implied sufficiency condition. And if you write that condition into the definition as well, it looks like this, then you can very reasonably interpret the definition as stating that X is a necessary element of sufficient set. So the conditions are as follows. Sufficiency here is then characterized as, in this particular context, if we intervene to set X to its actual values, and there's also some other set W, and we set that to its actual values, then Y will take on its actual value. That's a sufficiency claim, right? So X is a member of a set such that it makes Y happen. And the necessity condition is then that there exists counterfactual values for X such that if we hold the rest of the set fixed and we set X to those counterfactual values, then all of a sudden Y would no longer take its actual value. So that's already a first way of interpreting sufficiency and necessity. which leads me to give you a broader view on how we could generalize that idea. So the above statement is the rough informal idea of sufficiency. What does it mean that a particular set of variables being set to a particular set of values is sufficient for some other set of variables being set to a set of values? Well, in the causal context, we're going to have to invoke interventions. If we set the variables in X to the values X through an intervention, then Y takes on the values that we're looking at. Now, this informal statement only says something about the variables in X and in Y. It doesn't say anything about all the other variables. And that's where we can still play with filling in the definition in more detail. Those are the parameters we have to impose conditions on. And so there's two groups of variables, right? Exogenous variables and endogenous. And for each of those, we can make further restrictions. So for example, if we're focusing on the exogenous variables, we can focus on all contexts. So we have universal quantifier over context, or we can focus on just in some contexts, meaning there's an existential quantifier. That's one choice we have. Another choice focuses on the endogenous variables. And the two extremes here are that we can demand that the other endogenous variables are left alone. So we don't touch them, we just let them get their value through the equations. And that's the weakest notion that I've written down here. So meaning in some context, if we set X to the values X and we do not intervene on any of the other variables, then Y takes on the value of Y. And that's what we see in the modified HP definition. But we might also demand something more of sufficiency. We might say, look, we also want it to be the case that Y is guaranteed to take on the values Y, even if we intervene in all the other variables. And that's what I call direct sufficiency. Now, there's also intermediate forms between those two extremes, and there's one in particular that I'll focus on, which I'll introduce shortly. So here it's just an illustration of how these notions work in practice. Imagine that we have the causal model on the left, where the graph is just to visualize the causal relations, and we're assuming that they're all binary variables. By the way, just the fact that I'm using binary variables, that's purely for illustration. It's nothing, there's no reason why we should restrict ourselves to those kind of variables. So here, if we think of this notion of direct sufficiency, which is what I call the strongest interpretation, then we get that C being 1 is directly sufficient for Y being 1. The reason being that if we look at the equations, the moment that C gets value 1, it doesn't matter what we do to any of the other variables, Y will be 1. So that's a very strong guarantee for getting Y equals 1. Likewise, for the set Z and X being 1, same property holds as for C equals 1. And likewise for C being 0 and Z being 0, being that's directly sufficient for Y being 0. Now, we do not get that C being 0 is directly sufficient for Y being 0 in this strong sense. And the reason for that is that we can find an intervention on the other variables. Namely, we can set X to 1 and Z to 1, so that even by setting C to 0, we don't get that Y is 0. And you might wonder, isn't that too strong a demand? Because in some sense, C being 0 is sufficient for Y being 0. Namely due to the fact that C determines entirely the values of Z and X. And C plus Z and X together completely determine the value of Y. So in that sense, C by itself is causally responsible for for the value of Y, even if that's 0. And this idea, what I've explained here is essentially I've taken the transitive closure of this notion of sufficiency. That's the notion of sufficiency that I prefer and that I call strong sufficiency, because it lies in between the strongest version, direct sufficiency, and the weakest notion. And so it simply is defined as a transitive closure of direct sufficiency. So again, applying it to our model here, we would get that C being 0 is sufficient for Y being 0 along a particular network. And we see that by splitting it up into several parts. C being 0 is directly sufficient for C, X, and Z being 0. And that set we've just gotten the sufficiency for, we can use that to say that set is sufficient for y being 0. So we just split up the jump that we made before into 2 steps, right? It's this 2-step relation to get from t being 0 to y being 0. And there's an alternative way of defining it, which I show in the paper, that's equivalent to the way I've just expressed it. The crucial idea is that sufficiency proceeds along a network. And the network consists of variables which are on a path between the sufficient set and the set that we're requiring sufficiency for. So sufficiency, that was the most complicated notion. So once we've set out how we can define that, we are ready to fill in the definition of actual causation. And this is merely filling in what I said before, namely you want to have a sufficiency condition and a necessity condition. And this is a bit more fine-grained because I've now already specified that sufficiency looks like this in its most general form. That we have a particular set of variables taken on their actual values. That's why there's the stars. And those are sufficient along a network. Now, if you want to look at the case in which we look at direct sufficiency, there's no network. So that just means that we take the network to be empty. So it's general enough to express the different notions of sufficiency that I've looked at. But the one that I'll propose as the best one does make use of this idea of a network. So the first statement is simply sufficiency. The second statement, which should focus on necessity, is a bit more subtle. So necessity here is interpreted as the claim that, or rather, that we're looking at counterfactual values for x, which cannot fulfill the same purpose as the original values could. But note that I'm not focusing on the same network here. I'm focusing on all the possible subnetworks or subsets of the network. And the reason for that is we're not interested as such in the network. The network N is merely a means to an end. What we care about is the role of the network in being sufficient for Y. That's why if we had found values X such that for a smaller set of variables, it was sufficient for Y, then it wasn't really the case that our original values, X star, were necessary. They were only necessary to get the entire network, but not to get a network such that we get Y, right? This sounds perhaps a bit complicated, but in the paper, I try to explain this as well. And these two conditions together give us one way of understanding actual causation as the formalization of the Ness intuition. Now, note that here I've interpreted necessity in a particular manner. I've interpreted it as looking at counterfactual values of X. That's one way of interpreting necessity, but another way would simply be to ignore X. Right, so this is a necessity as minimality, as I call it. So that rather than saying, so we have an original set of variables, X and W. What does it mean that X was necessary in this particular set? Well, it means that if we were to remove X and we're just looking at W, then all of a sudden it's no longer sufficient, right? And that's minimal necessity, as I call it. So what we have is two different ways of understanding necessity, both of which have some plausibility, and we can combine those with the 6 definitions of sufficiency that I've defined in the paper, and which I've given you a rough sketch of using the illustrations. So if you combine all of those, we get this list, and the question becomes which one of those definitions, all of which are conceptually speaking formalizations of the Ness intuition, which of them fares well in practice and also has some nice properties that we would expect of causation. And so the 12 definitions, first of all, as you can note, the first 6 have the contrastive interpretation of necessity. The second set of 6 have the minimal interpretation. And so first claim I'm making in the paper is that the contrastive interpretation, which is explicitly counterfactual, is a better way of looking at necessity than the minimal one. Then we have to first select the notion of sufficiency that we like. And as I've already said multiple times, I believe the notion of sufficiency along a network is the one that's most suitable. So we're going to dismiss the options of using weak sufficiency or direct sufficiency. That leaves us with a choice between actual and, well, non-actual. I didn't put the word there because it just seems like quite obvious that if you remove actual, it's not actual. And this choice, we don't have to make it. Because one of the results of the paper is that for this particular couple of definitions, definition 2 and definition 5, which only differ regarding are we demanding that this condition holds over all contexts, or are we demanding that it holds over just one context? They're equivalent. They satisfy the same, they have the same extension. So then I just opted for the one which focuses on the actual context because that's easier to work with. So we're left with one definition. Now, I haven't really given you that much insight into why I think this is the best definition. I'm going to give you some in a moment. But before I do that, let me also at least give you an example to show how this definition that I've now selected works in practice. And this is an example from Halpern and Pearl, which they give as a test case for any sensible definition of causation. So suppose that a prisoner dies either if X loads D's gun and D shoots, or if A loads and shoots his gun. So we have 3 people, X, D, and A. And A is a person who can shoot all by himself and load the gun, whereas X is an assistant of D, so X has to load D's gun and D is the shooter. Okay, so suppose that in this particular situation, X loads D's gun and D does not shoot. And we're just using binary variables to represent this. Also, A does load and shoot his gun so that the prisoner dies. It's a very violent example, but somehow in the philosophy literature, all these examples are very violent. So that's just the imagination, I guess, of academics. In this situation, right, we have A shooting the prisoner. And so clearly we want to say, sure, A shooting is a cause of the prisoner being dead. So the prisoner being dead here is Y equals 1. Yet we would not want to say, and again I'm quoting, we would not want to say that X equals 1 is a cause of Y equals 1, given that D did not shoot. So X equals 1 here represents X loading D's gun, and D being 0 means D did not shoot. Right? So there was no bullet that left D's gun. So the fact that X loaded the gun still doesn't justify calling that act a cause. Now, if you want to represent that using a causal model, there's only one equation that's non-trivial, namely the equation for the prisoner dying. And in this case, there's 2 ways that can happen, either by the conjunction of X and D, right, loading the gun and D shooting, or A shooting the gun. And then there's a context that comes with this story stating that it is the case that X loads the gun, A shoots, and D does not shoot. Now, how would the definition I've just chosen handle this? We have to look at sufficiency. So is X being 1 sufficient, or is it a necessary member of a sufficient set for Y equals 1? So we have to go and look at all candidate sets of actually satisfied values and see if any of them is sufficient. So we start with X by itself. That's clearly not sufficient for Y being 1, because if D and A are 0, then Y would not be 1. So X by itself is not sufficient along any network. Here we don't even need to speak of a network because X, D, and A are all parents of Y. So it's a very simple example in that regard. If we look at X and the actual value of D together, they're also not sufficient, because if A doesn't shoot, then those values would not guarantee that Y equals 1. This leaves us with the last candidate, X being 1 and A being 1. And indeed, that is sufficient for Y being 1, right? No matter what we do, if we have those actual values, then Y will be 1. That's the first part, sufficiency. Okay, we found a set which qualifies for sufficiency of X being a member of it. Now we have to look at whether X was a necessary element of it. And here in this case, that's not true, because if we set X to 0, as long as we have A equals 1, we still have a sufficient set. Therefore, X being 1 is not a cause using the definition that I've just proposed. Okay, now let me just say a bit more about how I went about selecting the definition, other than the very rough sketch that I gave. And some of it is based on theorems, some of it is based on examples. So we start with 15 definitions, right? 12 definitions that I've sketched and 3 definitions of HP. We want to get down to one. One definition is impossible to satisfy. It's contradictory. So that's great. We can dismiss it. Then there's a theorem which shows that several of these definitions are actually equivalent to each other. So that narrows it down from 14 to 8. We can get rid of 6 definitions. Then there's a principle which alludes to this importance of counterfactual dependence. So although everybody agrees that it can be necessary to demand counterfactual dependence for causation, there is widespread agreement that it should be sufficient. And that's what this principle states, is that we would expect a definition of causation to satisfy it. And there's 2 definitions which do not satisfy it, so we can get rid of those as well. Then the further selection is made by looking at the work of Halpern and Pearl themselves and seeing what reasons they give for dismissing their prior definitions. So they dismiss, for example, their original definition based on a set of examples. And using those examples, we also get 2 further definitions of our list, which also get dismissed. Then they make a further comparison between the modified definition and the updated definition, arguing that the modified one does better. So we also forget about the updated one. And that leaves us with 2 definitions, the modified definition and definition 2. And there I make the final selection based on a bunch of examples, but also based on the demand that a definition should show consistent behavior across examples which are very, very similar. Now, this is still to a certain extent subjective, because what does it mean that the examples are very similar? But I believe that I made a convincing case in this regard. So this is the setting. We have, again, the causal model that I've already introduced for the example with the prisoner and the shooters, except that we're going to play around a bit with the relation between A and D, so the 2 shooters. We can play around with 6 variations. We can look at a situation in which D is itself determined by the context, and so is not related to A at all. And then we can look at whether D is 1 or D is 0. But we can also look at situations in which A is a cause of D, or vice versa, where D is a cause of A. And again, we can split those up into 2 cases, namely, is the causal relation such that they have the same value, or do they have opposite values? So all in all, these are 6 different cases. And we can assess how different definitions of causation judge these cases, which are very similar. And then we can ask, does a definition offer consistent answers across these variations? So the easiest case is original definition of Halpern and Pearl, because it says that X, in this situation, X being 1 is always the cause of Y being 1. Also, I should clarify, we're looking at situations such that always X is 1 and A is 1. So the only thing that's changing is the value of D and the causal relations between D and A. My definition says, well, for X to be a cause, it needs to rely on D being 1. That's the only thing that matters. Everything else is irrelevant. So that's its judgment. As long as D is 1, X is a cause. If it's not 1, then it's not a cause. So I'd say that's a pretty consistent answer. Yet if we look at the updated and modified HP definitions, then they flip-flop between calling it a cause or not, even regardless of whether D is 1 or 0. So there might be some further reason as to why the definition should behave that way, but without further argumentation, I'm going to conclude that it's not a satisfactory answer. And that brings me to conclusion, which is that I've presented to you a definition of actual causation, which is highly dependent on invoking the notion of causal sufficiency. And by the way, this work has been published in the Journal of Philosophical Logic, in case you want to have a look at the paper. And the main idea is that we should define actual causation based on the fundamentals, so on principles, rather than looking at examples. I've given a family of definitions of causal sufficiency, and in the paper I suggest that people can play around with even other definitions, and using that notion of sufficiency, we have a recipe for defining actual causation as the Ness intuition, namely being a necessary element of sufficient set. And then with all these definitions at hand, I've selected one which I believe is superior, and suggest that as a new definition of actual causation. Now, an interesting result, which is quite recent, is that I've written a different paper, which is available on the archive, which focuses on causal explanations and asks the question, what do we expect of an explanation such that it can guide us to actions which ensure particular predictions? What are the properties of such explanations? And that's because of the emphasis on XAI, explainable AI. That's the context in which I'm asking the question. And it turns out that if you look at sensible properties of such explanations, you end up with the same notions of sufficiency that I've given here. And if you want to then look further into the question of actual causation, so that you want to have actual causes be good guides to action, then you end up with the same definition as the one that I've just presented. So those are two, you could say, significantly independent paths of arriving at the same result. So let me now stop there and just briefly state that this work was funded by Alexander von Humboldt Foundation when I was still in Munich last year, and that I want to thank several people for providing comments on the earlier drafts. Thank you, and I'm very much looking forward. Oh, and I should also, of course, thank Thomas. I'm very much looking forward to what he has to say now, next 10 minutes.
Thanks for the very nice talk. I think we can maybe just squeeze in one very short question. So one attendee asked, can we generalize this to continuous variables? So how would you then measure whether Y is sensitive to X, or have you any thoughts on that?
Yeah, continuous variables as such, there's nothing preventing variables being continuous. It's just that in practice, it might be too easy to be a cause if you're applying my definition as is to continuous variables, in a sense that in many cases, it will be such that a variable could have a really tiny impact on the effect variable, such that if you're really focusing on the precise value, then wiggling around one variable might give a difference in the effect variable, but that seems too easy. So then we might say, okay, it should be that there's a certain range or a certain degree of difference in the effects before we consider something to be a cause. But as such, the same idea would still apply to continuous variables. And also I see a question regarding potential outcomes. Yeah, obviously I should have anticipated that. So I'm not at all working with within the potential outcomes framework. And as far as I can tell, almost all work on actual causation proceeds within the structural equations modeling tradition. I'm not sure if there's a really fundamental reason for that, or whether it's a matter of habit and sociology. I don't know enough about that.
All right, thanks.
Okay, great. Thank you, Sander. So we will move on now to the discussion. So Thomas, please feel free to take it away.
Great, thanks. Let me see if I can share the screen here. And okay, is that showing up? Great.
Yes.
Okay. So thanks so much to the organizers for this, and to Sandra for the really fascinating and rich talk and paper. I wanted to just quickly go through a few things in my short comment. First, just to recap what the positive proposal is that Sandra is making, this view that in the paper he calls MCNSSSS. And then raise a methodological question that actually Sandra also addressed in the talk for a moment, and then consider some variations on some of the examples considered. Okay, so what is the view? Remember, we're in this situation where a whole bunch of things happened, a whole bunch of variables took on some values, and now we want to know when some set of variables X caused some variable Y to take on its value. And the proposal is that we should look for the existence of some set W and another set in that includes Y. And it first needs to be the case that if I hold X and W fixed at their actual values, then I can vary the background variables, all the other variables of it to anything. I can vary them however I want, and the values inside of in don't change. right? So I can change these however I want, and that's the sort of sufficiency notion that X and W are sufficient to guarantee that in take on these values. And second, we want this necessity notion, which asks us, is there some other value of the X's such that for any subset of n that contains Y, in any set of values for those S's, I can find some setting of all the other variables that will actually change some of the values inside of S. Okay, and I want that to hold for every subset of n containing Y in any set of values I give to those. So this is a somewhat complex definition. It's an exists for all exists. So we want to know, why such a complicated definition? And of course, the motivation, as Sander pointed out, is several. One, possibly to connect up to notions of explanation and action, but also to capture a whole bunch of intuitions that people have had in this literature. So I wanted to mention one that didn't actually come up in the talk, but is very closely related to the ones that did come up in the talk, and that's the major and the sergeant. Here we have a major and a sergeant and a corporal, and the corporal listens to the major and charges if the major says to charge and doesn't if the major says not to. And in one case, if the major is just silent, then the corporal listens to the sergeant and charges depending on whether the sergeant says to. Okay, so that's a little causal scenario, and I'm going to somewhat provocatively write the equation like this because it looks very similar to some of the equations that we saw in Sander's talk for the other examples. It's actually a kind of variation of some of those. And the intuition that people have in this case, in this literature, is that M, if we want to say, so suppose M and S both set to charge, and so the corporal charged, people have the intuition that M was a cause of the charge, whereas S was not a cause of the charge because, intuitively, the corporal is not even listening to S at this point because they're just listening to whatever M says, whatever the major says. Okay, so that's the type of intuition that this proposal and some of the other proposals earlier were motivated to capture. And so now I want to sort of step back a moment and consider some of the questions that Sander addressed at the very beginning and the end of the talk. Namely, what is actual causation and what do we want from a theory of it? It's a very general question. And you can imagine several different ways of approaching this question, several different types of projects. The first one, which to my mind, to my understanding, is not what people are up to in this literature, but could also be interesting, is to codify some concept that's already at work in some domain. So maybe you could try to figure out what are historians, for instance, interested in when they're trying to figure out what caused what in some historical example, and so on and so forth. So that's one thing that you could be up to. But another thing that you could be up to, another kind of project, would be to try to capture our ordinary intuitions about claims involving words like cause and because. And I think this is actually much closer to what this literature has been doing. And the question immediately arises, whose intuitions, which examples, how do we actually investigate this? And in the paper and in the abstract of this talk, Sander's very admirably clear about what the sort of rules of the game are. We're taking the examples and the intuitions of Halpern and Pearl. So that, of course, makes rhetorical sense and is makes sense in this context. But I want to mention a whole bunch of other work that looks at this from a slightly different perspective of actually just testing the intuitions across a wide variety of examples in controlled experimental studies. So the big literature on actual causation in psychology and cognitive science that is dealing with some of the very same kind of problems, some of the same types of intuitions, but different things have come up in those contexts. And I want to mention just one and maybe ask about how it relates to some of what we've heard about today. So this is some of our own work on the role of norms in actual cause judgments. So the scenarios are similar to those that Sander presented. For instance, imagine we had two bureaucracies, A and B, and we have some Professor C who needs a new computer. And C needs to submit an application to get a new computer, and she'll get her new computer just in case both A and B approve the application. So it's a simple little conjunctive scenario. And furthermore, suppose we have it that B almost always approves these applications. So we have a little bit more information than usual, some probabilistic kind of information or statistical information. We have that B almost always approves and A almost never approves. Okay, and now suppose one day C comes in, applies for this, this new computer, and B approves as usual, and A also approves. So C actually gets her new computer. Then a kind of pattern that's been replicated probably hundreds or at least dozens of times is that people tend to judge A to be a better cause than B of C. So people tend to think that C got the new computer because A approved the application. And this observation really goes back even to Hart and Honoré in the working on concepts of causation in the law. And this is a very well-attested pattern. So in this work, we were also interested in what happens when you vary the causal structure. So suppose you instead make this a disjunctive situation. So in order to get the new computer, Professor C just needs to have one of the two bureaucratic entities approve. So if B approves, then she gets her new computer, and if A approves or if both approve, then she gets the new computer. Okay, so that's a slightly different situation. But now again, suppose that typically B does approve, and A almost never approves. In this case, if in some situation C applies, B as usual approves, and then A also somewhat surprisingly approves, then people are much more inclined to judge that the typical cause was actually a better thing to cite as the cause. So the judgments actually reverse in this case when it's a disjunctive situation. So you can imagine these kinds of considerations about normality. There's similar results about morality, sort of moral norms and typicality and so on, is something like sitting on top of an account of actual causation of the sort that Sander presented. So basically a notion of actual causation like the versions that we've seen today basically would tell us what gets in the game as a cause at all. And then there's a further question, as Sander mentioned, as to which do we sort of select? What's the causal selection problem? How do we sort of pick good or better or worse causes? And so that's a compelling view. I want to maybe suggest that there might be something, there's sort of a puzzle about that view, and I want to consider just a variation of this example to illustrate the puzzle. Imagine it's the very same scenario, but now actually it's structurally exactly like all the cases that we saw that motivated these very accounts. Okay, so this is actually the very same, structurally this is the same thing as the corporal and the major and the sergeant example. So what's this situation? It's again, to get the new computer, you need either B or A to approve. But now suppose the situation is also such that A, this bureaucratic entity A, is slightly above bureaucratic entity B, such that they can actually overrule whatever B says and say, no, you don't get your computer at all, even though B said you can. Okay, so they have the ability to do that. Let's suppose, again, as a matter of norms, that they almost never do that. It's hardly ever happens, and moreover, it's frowned upon. It's considered bad form to use their power in that way and to say that B doesn't get to approve it. But nonetheless, it's there as a possibility. So this is actually the causal structure. So the question is, if we just tweak the scenario slightly such that this happens, would we all of a sudden, in accord with the views that we've seen presented today, judge B not to be a cause at all? And then likewise, if we do admit that it's a cause, would it still actually be similar to the case where you don't have this sort of extra option? Would it actually be judged a better cause than A still in this scenario? So that's a question, it's an empirical question. And I would hypothesize that actually B still is judged to be causal, but we could, of course, just put that to the test. I'm curious what others' intuitions are about this case. So let me just conclude with two broad questions. The first is, when incorporating all of these considerations that we know matter for people's causal judgments, actual cause judgments, norms, probabilities, morality, and so on, will this just be a conservative extension of a purely deterministic account like the ones that we've seen today? Or do we need some more radical kind of departure from this way of defining actual causation? And second, the second thing is, I think, just actually an invitation to Sander to say more about some of the stuff that he ended with, which is what kinds of data or results or facts should we actually use to determine when we have a good theoretical account of actual causation? So I'm looking forward to hearing some wisdom about this question as well. So thanks again to the organizers and to Sander for the really terrific work here. And I'll stop there.
Okay, great. Thanks for a really interesting discussion. Sander, do you want to answer maybe some questions that Thomas raised, or comment on it?
Yes, I can. First of all, next time I'm gonna steal your slides, because your graphical way of conceptualizing my definition is much easier to grasp. The easy answer is I'll follow up on all of this in future work. And the hard answer is that won't be possible to give, because I do think these are extremely important issues that you've highlighted, and I'm completely on board that we need to figure out the causal selection problem in addition to the purely definitional question that I've been asking, because they work as a tandem, in a sense that if you actually want to apply your definition of causation, but it doesn't address issues of normality, then what have you really done, right? So I definitely think it should be addressed as well, but I am, to answer your first question, of the opinion that it will be conservative extension, in the sense that I think it will be a matter of adding extra elements to it. So for example, probabilities, that seems a very sensible thing to look into. Another issue is how much, and this is addressing both the first and the second question, how much value and authority should we grant to people's actual judgments? And I'm inclined to be more of a prescriptive type, so that I feel that causation is somewhat of an expert topic. And just as with other expert topics in science, it's okay for people to be corrected. And we just say, look, you might have these intuitions, but that's not the notion that is most salient for explaining and thinking about the notion of causation that we use in science and in society. And in particular, this holds, I think, when it comes to responsibility judgments. So at the moment that there's anything of a moral nature involved, and the particular causes or actions of agents, then the conflation between responsibility and causation can create a lot of misunderstandings. But of course, you know that because that's been widely discussed in literature as well. In particular, the example you give, the disjunction, the conjunctive scenario, I should point out that there's another paper which will be published soon on moral responsibility, in which I actually explained the literature, the findings on the discrepancy between how people judge those cases by invoking a definition of responsibility that takes into account the epistemic state of the agent doing the causing. And the epistemic state of the agent, I do think, is a very salient feature when we're thinking about responsibility. So when it comes to selecting degree of responsibility, I would very much go on board with giving importance to the empirical findings that you've discussed. But when it comes to a degree of causation, I would push back a little and say, I think in this particular case, people are confusing responsibility and causation, and I do not necessarily want to say that the one is more a cause than the other. Depends on whether typicality and normality here takes on a probabilistic reading or not. So let me just simplify the answer by saying, I agree that those parameters matter, and they should be extended to give a full account of causal selection as well. That's definitely something I would hope to do. Regarding the particular example of the major and the sergeant, I was a bit confused by your variation, because it is crucial for the original scenario that both the major and the sergeant give the order to shoot, right? So if that holds, whereas it seems to me that your situation, it wasn't so clear to me whether you were also demanding that in this particular case, the higher ranked officer was saying something, or whether they were merely remaining quiet, because I would say that's a very different scenario. But in any case, that's it for now, and I completely agree that those issues are of crucial relevance to the problem.
That's wonderful. Thank you, Sander. So since we're over time, I think we'll wrap up, but this has definitely raised some interesting questions, I suppose, for the future. Just give me a second. All right. So next week, we'll have a talk by Zimei Ren from University of Chicago on sensitivity analysis of individual treatment effects, a robust conformal inference approach. Thank you all for being here. I'd like to thank again Sander and Thomas. This was really interesting, also something very new for me, but I really enjoyed both talks. Yeah, thanks again for being here. And